All right, this part of the project is not going to look all that impressive. This is kind of temporary. My dog really wants on the seat, but I don't really want her to jump over the Megasquirt board. Sorry, girl. Just stay on your own chair. Oh, I'm sorry. Back up. All right, so what we have on the chair here is a Megasquirt 2 board. And this might look a little odd because it's burnt up. This is a damaged board that I repaired. That's why you have these cables hanging off to an off-board connector. It's still functional, but it is damaged. So this has been kind of my bench mule prototype board. It's been soldered on plenty to reconfigure it for different applications. I have another board that I might use for this, but since this is kind of a low buck project, I might just zip tie this in place and keep using this board until it really dies. It does have a Megasquirt 2 chip on it, which is the brains of the operation. This is a DIY auto-tune harness running through a hole I drilled in the firewall. I have a fuse block just for the stuff I've been adding, the fuel injection stuff. I've run a new main power lead with a new main relay. It's good to have the same source of 12 volt and a good clean ground to the engine with Megasquirt, because your sensor readings are going to depend on that. The other important thing we have here is the Innovate MTXL wideband oxygen sensor. So that's got the controller built into the gauge here. It is feeding the signal to the Megasquirt and giving me a readout. So that's pretty important. I have a header on this engine, and I welded a bung for the oxygen sensor into the header. So should be a nice clean reading. I don't have the wiring all done yet, but we can take a quick look under the hood and show you what I got. All right, so I just drilled a hole in the firewall here. I will put a nice grommet in that to keep it from chafing the wires, but I wanted to get started, so drilled a hole and carefully fished the wires through. Down here, I don't know how well you can see it with the lighting, but we have the wideband oxygen sensor on the manifold, and we have a nice heavy ground going to the engine block. Up here is the body ground point, where I have the Megasquirt grounded along with the wideband and the main feed from the engine block and the battery. So the grounds are all tied together, and hopefully everything's of the same ground potential and going to give us a good reading. So of the wires we have here, these are the necessities and some extras. The necessities being your coolant temperature sensor. That's a very important one for Megasquirt to know the temperature of the engine. This is the intake air temp sensor. It wants to know temperature of the air coming in, the density of the air. It's going to change how much fuel it takes. Ground, sensor ground. Make sure you have a clean sensor ground. So in this we have 4 wires, which are the idle air control motor, stepper motor control wires. 4 of these are injector drivers. I only have 1 injector, but your standard ECU or your standard Megasquirt ECU is set up for 2 banks of injectors, and it gives you 2 wires each just to spread the load. You've got your 5 volt reference wire, which is going to be used by your throttle position sensor and your map sensor. And that is the gist of it here. Yeah. Stepper motors for the idle air, fuel injector banks, throttle position sensor, map sensor, coolant temperature sensor, intake air temperature sensor. Over on the other side, this wire running over here, that is a shielded wire, which is plugged into the negative side of the ignition coil. That's basically telling the Megasquirt the RPM. And then this wire here is for future use. This is going to be the spark output from the Megasquirt to trigger the ignition coil. We're not doing that just yet. So, on this side of things, this is a Pertronix Flamethrower, Flamethrower 3 ignition coil, just a hotter drop-in canister style replacement with the ballast resistor on the other side here. This is a 2-wire plus shield cable from the Megasquirt. They have a shield on here to eliminate any kind of electromagnetic noise from other components of the engine. Gives you a nice clean signal. Would be used to come from your crank sensor generally. In this case, we're doing coil negative triggering. We're not doing timing control with this in the first stage. I do intend to do that, but not quite yet. The way I will accomplish that is by using a documented procedure on the Megasquirt documentation. I think DIY AutoTune has that particular documentation. But you can use a Pertronix igniter, which is a standard points replacement item that you can put inside pretty much any distributor. That's basically a flying magnet VR sensor. So that can be sent to the Megasquirt over this wires. See, well, right now I only have 1 wire hooked up. You got 2 wires coming off the distributor, off the Pertronix igniter. You can wire the Pertronix igniter directly into the Megasquirt, so it can use that as its RPM reference and spark reference, and then have the Megasquirt trigger your coil directly. So right now I have the Pertronix igniter triggering the coil and the Megasquirt just reading when the coil fires. Your timing's going to change based on RPM and vacuum. However, if you lock out those mechanisms and set the distributor to a specific angle that gives you enough overlap in your distributor cap, as far as the words escaping me, but it's basically called distributor phasing. If your distributor rotor relationship is set up to the cap just so, you'll have enough sweep through there where you'll have a range of available time that you can fire your ignition coil. So if the Megasquirt knows when or where that's set, and the Pertronix is telling it what position the engine is in, then it can modify the time that the ignition coil fires, therefore effectively controlling your timing using nothing but the Pertronix igniter, which you probably already have. If you don't, you should. And your standard ignition coil. So that's basically $0, I shouldn't say $0, whatever Pertronix igniter costs, 30 bucks. I bought it years ago. I don't know how much it costs, but a very low dollar way to get control of your ignition timing. Again, that's not phase 1 on this. I'm going to be doing my fueling first. Fueling is the easier thing to tune. To tune your timing properly, you really need to have the car on a dyno. However, this is a mechanical distributor. You can look up or test to find a pretty good idea of what the ignition curve is over RPM. So you can program that into the Megasquirt, at least, and it can estimate that sort of thing. But to really get it dialed in for maximum performance and efficiency, you're going to want to put this thing on a dyno. So I might actually do that. I might take this to town and get it dyno tuned after all of this work is done. So that's the quick rundown of Megasquirt wiring. There are a few other things to consider, which I will delve into a little bit deeper as I get things accomplished. So right now I just have the wires kind of laid out. I still need to add a power lead for the fuel injectors themselves, and I need to really wire everything into that throttle body. Still some work to be done, but the system that I'm going to be setting up here with the Pertronix igniter and the throttle body injection, it's really pretty simple. So hopefully it will also be effective and reliable. We'll see. So I will be putting in some more work on this over the coming weeks, and hopefully we'll be driving it as a fuel injected car here soon. So stay tuned, and hopefully I'll be able to take you along for the ride and won't light anything on fire. All right, catch you next time.